Hi everyone, I'm gonna walk us through more of the polar coordinates that we were working on last time. If you were not here on Tuesday, you should actually start by going to the Tuesday folder in Schoology and taking down kind of the basics as to what polar coordinates are, as that's gonna be the first half of your assignment, which is a Math Excel assignment. Okay, so again, if you weren't here Tuesday, go ahead and I'd pause right now and go get those notes from Tuesday as they are pretty simple. But for today, what we're going to do is we're going to talk about the relationship between polar and rectangular coordinates. Rectangular coordinates being the ones that we're used to, so like x comma y. So remember, with polar coordinates, we have a value of r. That's going to be our kind of distance from the center, or it was referred to as the pole, is the more formal name. And theta is the amount of rotation, just like when we were drawing angles. So the first thing that you're going to want to do is jot down these equations. This is going to help us go from either polar to rectangular or vice versa. And one thing that I want to do with this equation here, because you're going to see me kind of take a shortcut to it, is yes, it's x squared plus y squared equals r squared. That's just derived from the Pythagorean theorem here. We're going to need to solve for r in some cases. So if I just take the square root of that, a form that we're going to use more often is just this r equals x squared plus y squared. We'll end up taking the square root regardless, but if we just remember the equation like this, we'll save at least one step. All right, and I'd also get down that tangent of theta is y over x, which we already know. These are the two that are kind of new to us. Okay, so go ahead and hit pause. Go ahead and write all these equations down. If you want to write down the diagram, you can. It does do a pretty good job of, again, explaining that in polar and rectangular coordinates, we get a point in space. Okay, so there is a relationship between the two, and that's what we're going to work on, is taking a polar coordinate, converting into our rectangular or xy coordinate point. And then we're going to do the opposite, and that's really all that we're going to add on to the work we did on Tuesday. So let's jump right into it. Hopefully keep this video pretty short. So it says find the rectangular coordinates. So that means we're looking for x comma y of the points of the following polar coordinates. These are polar right now. So remember, this is r and this is theta. So basically what we're going to do is we're going to use these top equations to find x and y, and that's really it. So pretty straightforward here. So x equals the r value, right? So x equals r cosine of theta. So 2 cosine of 3 pi over 2. And all we need to do is evaluate or find that value. So we are going to need a unit circle. Again, if you can do this without the unit circle, even better. Hopefully you have one. If not, you can pull it up real quick. But basically, I need to find the cosine of 3 pi over 2. So I find 3 pi over 2. Cosine is the x coordinate. So cosine of 3 pi over 2 is simply just 0. So x in this particular case is 2 times 0, which is 0. We have found the x coordinate of this particular polar coordinate. Now for y, it's basically the same, just 2 sine of that theta. So 3 pi over 2. Again, on that unit circle, I'd go to the same value. 3 pi over 2, sine is the y coordinate, which is -1. So this is 2 times -1, which is -2. So 2 comma 3 pi over 2 in polar coordinates corresponds to 0 comma -2 in our rectangular coordinate plane, which is our x comma y or Cartesian plane that you are all used to. And that's it. So not too bad here. Let's do one more with b here. So value of -8 and pi over 3. So again, we're going to find x equals -8 cosine of pi over 3. So that's -8 times, well, cosine is the x coordinate pi over 3, which is 1/2. Not too bad there. -8 times 1/2 is -4. That part is done. And now for y, -8 sine of pi over 3 is -8 times, well, that's pi over 3. The y coordinate is √3 over 2, which that ends up being -8 √3 over 2. And then always make sure you're simplifying this before you type it into Math Excel. -8 divided by 2 is -4, so this ends up being -4 √3. So -8 comma pi over 3 is polar coordinates, corresponds to the point -4 comma -4 √3 in our rectangular or XY coordinate grid. That's it. So that is us converting from polar to rectangular. Again, if I get going too fast, what's nice about a video is you can hit pause, you can jot down the notes, you can rewind. So of course, make sure you're utilizing the fact that you can pause it, slow it down, or rewind. All right, I've got 2 more examples for us. We're gonna do the opposite. And when we do go from rectangular points in the polar coordinates, it's gonna be a little more work. So there's some more things you're gonna need to jot down. And just like I just mentioned, not gonna just wait on the video for you to write these down. So you're gonna wanna hit pause. You're gonna wanna write all these things down. Okay, and I'll walk us through it real quick. So converting a point from rectangular to polar coordinates, we want R to be positive, and we want our value or our angle of theta to be between 0 and 2 pi. Okay, so those parts are important and going to kind of help us get to the exact point we're looking for. Because remember, one thing we did last time is we wrote polar coordinates in multiple different representations. So this is going to make sure that we only get one specific point. So the first thing is we need to plot x comma y. This is going to help us pin down the value of theta. You'll see that when I get to step 3 in the one particular example I'm going to go through. Then we're going to find r. This is why I had us go from r squared equals x squared plus y squared to be r equals the square root of that. So we can just simply plug in x, plug in y, and find the value of r pretty quickly. And then we're going to need to find theta by using the fact that tangent of theta is y over x. And we need to figure out, okay, where is theta located based on where that point is located, which quadrant, right? So again, go ahead and hit pause, write everything down I have in the box. Maybe you can write down the example here, where this is r comma theta. And we're going to work on, or excuse me, not r comma theta, x comma y. And we're going to work on getting it into polar coordinates. Right, so step 1 says to plot the point. We don't need this to be exact. The only thing that we need to do this for is to figure out which quadrant is it in. So -1, that means I'm going to go left. √3, that's positive, so I'm going to go up. So it's somewhere up in here in quadrant 2. That's all that we need to figure out. So do you need to plot it? No, but you want to take note as to which quadrant does this fall into, because again, that's going to help us find the exact value of our angle. Then we're going to find r by taking the square root of x squared and y squared, so -1 squared plus √3 squared, which is the square root of 1 plus √3 squared. The squaring and the square root cancel out, so 1 plus 3, r equals square root of 4, which is 2. Okay, we want r to be positive, so even though we take square roots and it can be plus or minus, we are going to let r be positive, again, just to make it more exact and get that specific point. So the last thing we need is our value of theta. And this is where a lot of our work with inverses are going to come right back. So tangent of theta is y over x, which is √3 over -1. It doesn't matter where that negative goes, and that shouldn't be news to us. Okay, it's -√3. So this can also help us figure out where that angle is located. You can also just look in the first quadrant, but right, with tangent of theta being negative, we know that y over x, we need one x coordinate to be negative or the y coordinate to be negative, not both. So you could look here and figure, okay, where am I going to get √3? But I can also just go ahead and look in quadrant 2, because that's where I'm going to get a y divided by x to be negative. So remember, tangent's a little weird because I can't just physically look at, okay, where do I see √3? We can pin it down and get an idea as to where might it be, either at 2 pi over 3 or 5 pi over 6. But we still need to do some work, because I can't imagine that most of us have the values of tangent memorized. So I'll just start with this top one here and see if I take this value of y and divide it by x, does that get us to -√3? So at theta equaling 2 pi over 3. Okay, and this is just some side work. This is separate from me. This is more of me checking to make sure that at 2 pi over 3, I get this coordinate. And that may or may not work out. We're seeing what is y divided by x. So that's √3 over 2 divided by -1/2. So to find this value, I'm going to copy the top and multiply by the reciprocal of the denominator. 2's divide out, and sure enough, we get -√3 over 1, which is exactly what we're looking for. So our value of theta in this particular case is 2 pi over 3. And so remember, when you get to this point here, this is really us finding the inverse tangent of -√3, or in other words, At what angle do we get a coordinate of negative root 3, where tangent is y over x? So you're going to want to continue to think about some of our equation stuff and inverse stuff to find our angles here. Now, the last thing that we want to do is once we find this angle, we want to make sure that that particular angle is in the correct quadrant. Since we paid attention to the fact that y divided by x was negative, and we already looked for our radian measure in quadrant 2, we've basically taken care of that, right? Where 2 pi over 3 is in quadrant 2. So I actually don't need to do any extra work there. The fact that our point was in quadrant 2 and the fact that our angle got us to quadrant 2 mean that it all worked out. We don't need to do any extra work. All right. So -1 comma root 3 as a rectangular point corresponds to the point 2 comma 2 pi over 3. Okay. And again, it might help for some of you to actually draw this out and make sure that if you were to plot this in the polar plane, like we worked on Tuesday, we'd have 2 circles out. 2 pi over 3 is the amount of rotation, so it brings us up into quadrant 2, 2 circles out, so somewhere up in there. Yes, these aren't drawn to scale, but this at least tells me that they're relatively close. Okay, I have one last thing for us. Actually works out much nicer and much more straightforward. And that's if a point x comma y lies, on a positive or negative axis. We just have to use some guidelines here just to make sure that, again, we don't want to represent it in multiple ways. We want to find the exact way, especially for your Math Excel assignment. So again, we want R to be positive just like before. And then we want theta to be the smallest, I'm going to botch this word, quadrantal angle that lies on the same positive or negative axis. So what the heck does this mean? This means that we are looking for angles on X or Y axis and being between 0 and 2 pi. Okay, so basically for this particular point, we're just going to have an X comma Y that lies either on positive X axis, negative X axis, positive Y or negative Y. We don't want to use a value of theta or an angle greater than 2 pi or less than 0. Okay, that just gives us some guidelines. So again, that we are describing one specific point and not a different representation of that particular point. All right, so again, if you need to hit pause, go ahead and write these down. Otherwise, I'm going to move on to your last example, and you're going to see that these work out much quicker because finding the angle theta, since we are on one of the axes, is really easy. So last example is it says find the polar coordinates of the point whose rectangular coordinates, that's x comma y, are -2, 0. Well, if I were to plot -2, 0, we find that it is on the negative x-axis. Okay, it shows us the value of r. It's pretty easy because that's how far we are from the center. It's 2 units. We can still solve for that. I could still say that r equals the square root of x squared, so -2 squared plus 0 squared is the square root of 4 plus 0 squared, so just root 4, which is 2. So r is 2, not -2, because if you look at your guidelines that you just wrote down, we want r to be positive. Now for our value of theta, we know exactly what this value of theta is. That was one of the first things we memorized when we started talking about the unit circle. So out at the negative x-axis, that is just simply pi. And that's it. You don't need to do tangent of theta as y over x. You can if you want to, it's just more work. But with it being on one of the axes, it's really easy for us to find the particular angle that we rotate to. So -2, 0 in rectangular coordinates corresponds to 2 comma pi in polar coordinates. Right, well, you are all set to complete the rest of your Math Excel assignment. Thanks for watching and have a great rest of your day.